Okay, so we are going to go through electricity, questions on electricity. We did part 1 on the concepts. So now we're going to go through some of the questions and use the concepts to answer the questions. If you have not watched part 1, please check out my other YouTube videos and you will be able to find part 1. And if you have not subscribed, please consider subscribing so that when I upload videos, you'll get notifications. Alright, first question. Don wanted to find out how the arrangement of bulbs in a circuit affects the brightness of bulbs. This is a common question. It doesn't have to be concept or topical based, because this is a variable question. So in every experiment, by right, there should be only one change variable. Okay, and the change variable is what we are testing. So that's something that you have to remember. So we are trying to find out the arrangement of bulbs. How arrangement of bulbs affects, okay, this is an important word I mean. So this is the change variable, affects the brightness. So this is the result. So the word affect, okay, it separates two things. It separates the change variable. That means if you are not sure what change variable means, in every experiment there should be a change variable. The change variable is for you to sort of compare the results, which is the next part here. After the word affects will be the result, which you measure, to see whether that particular thing that you change has any effects on the result. Okay, so here we are trying to find out if we change the arrangement and then when we record the brightness of the bulbs, will there be any change in the brightness of the bulb? So that's something you must remember. So this is the result that we usually record. Okay, so result that we usually record. So can we change the number of bulbs? Of course not, because we already say the change variable is only the arrangement. Now the brightness, if you have a table, you will see that the brightness will change, but the brightness is not a change variable because it's a result. It's dependent on the change variable. So we do not change the brightness also. Number of batteries, no. Okay, we can only change the brightness. So we want here to keep the same. So be careful what they are asking for. So all these three, we will keep the same. Alright, so it's A. Oh, sorry. We can't keep the brightness the same. Just now we already mentioned is the result recorded. So remember, okay, so the recorded result, you do not keep the same or you do not change. Okay, so here we do not keep the same or we do not change. So remember again, recorded result, we do not keep the same or we do not change. It's just something that we record, that's all. So the only thing that we will change here, okay, is the two things, or are the two things here. A, number of bulbs, number of batteries. So if you see the word affect here, you will not change this because this is the you will change this because this is a change variable and this is the recorded result. Alright, so the one that you will not change is these two, A and C. Okay, so this is how we answer this first question, and this is not topical based. Next, the diagram below shows 4 bulbs A, B, C and D in a circuit that is connected correctly. Which one of the bulbs will not light up? Now, electricity, I've always I always like to tell my students that this is like kindergarten work, because all you need to do is trace. Okay, so you start off from the battery, any direction, it doesn't matter. Okay, it can pass through A, but doesn't mean, one mistake when students starts to learn this topic, when they pass a bulb, straight away they say, oh, it will light up. No, you need to make sure that you have a way back to the battery to close the circuit. If it's not a closed circuit, that means by right the electricity will not even flow. Okay, so we'll go this way, copper. conductor of electricity. We learn metal is a conductor of electricity. Oh, so we will not go here. Okay, because it's a plastic rod. Okay, as you can see, this is just like kindergarten tracing. That's all. So it doesn't go there, so it goes here. Now, when it goes here, it goes down, iron block. Now, you won't go here. Okay, there's no reason for it to go here, because if it goes here, it goes up, and so it will not go back to, there's no path here. Okay, and it will not U-turn like that. Okay, so it doesn't go that way. So where does it go? It goes back to the silver ring and to the battery. So only two will light up, A and B. Okay, but we want will not light up. So the one that will not light up is D and C. Okay, because D and C here, there's no electricity flowing through. Alright, so that's the answer, number 2. Next question. Identical batteries and bulbs are used to set up the circuit below. Which are the following statements about the circuit is correct? B1 will light up when either B2 or B3 is lighted. So let's check B1. Okay, so there's no other way except to pass through B1. Alright, so there's no other way except to pass through B1. So B1 will light up as long as one of these lights up. If both does not light up, there's no path for the electricity. See? It stops. Alright, so but as long as one of them lights up, it will pass through and B1 will light up. So the answer is 1. But let's just go through all the options. It's good to go through all the options. Sometimes we can make a mistake. Okay, if we are rushing especially. At least one bulb will light up when S1 is closed. When only S1 is closed. No, when only S1 is closed, like we've mentioned before, there's no path for electricity to flow, because you still need to close either S2 or S3. So 2 is wrong. 3, electricity will flow through the circuit as long as one of the switches is closed. No, not again. You need to close at least 2. S1 must be closed, then either one of these. Electricity will flow through the circuit only when all the switches are closed. No again, because we mentioned either S2 or S3 must be closed. Alright, so next question. Join prepared 2 setups P and Q using identical batteries and light bulbs as shown in the diagram above. Draw in the wires in each circuit such that the bulbs in setup P will be brighter. We went through the first part. We want brighter. We want separate circuit for each bulb. So how do we draw separate circuit? Okay, we draw for each bulb first, like that. Okay, once we're done with this bulb here, we're going to draw for the next bulb. But we can use the same wire. Then we go down. Okay, and we go here, and we can use the same wire to go back. So this is how it looks like. And just to make sure that your drawing is correct, again, kindergarten work, you just need to trace. Make sure that when you trace to one of the bulbs, it doesn't pass through the other. Okay, so if we go through this one here, there you go. We don't need to pass through the other bulb. So if we go through this other bulb here, I'm going to use blue now. And you see, it doesn't go through the other bulb. So we are safe. This is correct. Now, if we want setup Q for the, the bulbs not to be as bright, or maybe dimmer, we can say dimmer, then setup P, we need to make sure, let's use the pen function. We need to make sure that they are connected in series and not in parallel. And we also talk about why it's like that. So a revision here, 2 battery with 1 bulb, 2/1, brightness is 2 units. Same for this one, 2 batteries share with 1 bulb, brightness is 2 units. While this one, 2 batteries passing through 2 bulbs, 2/2, 1 unit. And this is also 2/2, 1 unit. Okay, so that's how we answer this question. Next question. Jane made another circuit Y and connected objects A, B, C. So take note of the object. C is a plastic roller. So straight away, maybe you can indicate there insulator. Okay, you don't need to spell the whole thing out. Just anything. You can put even X as long as you understand it. She observed that none of the bulbs in circuit Y light up. Alright, this is explain. Explain is our favorite question. Alright, it's our favorite question. Why? Because we are going to do it a lot. Okay, so we're going to explain. We start with an observation. Now, remember one more thing. In science answering technique, we try as much as possible to use words from the question. Okay, we use words from the question as much as possible. Okay, so she observed that none of the bulbs in circuit Y lit up. Explain why. So we say object. Okay, let's see. Let's find the word. Say objects. Okay, so they use the word objects A, B, C. So we're going to use the word object C is a plastic ruler. So again, where did I get all these words from? From the question. This is the word object. This is C and plastic ruler. All from the question. Now, this is just the observation. If you follow again, you will understand or you will remember that we have a certain way of answering. So this is our observation. Our concept, we will say an plastic ruler is an insulator of electricity. And well, okay, maybe we just stop there. It should be clear enough. Insulator of electricity doesn't allow electricity to pass through. And then we say the next part. And electricity has to pass through object C to form a closed circuit. Okay. Then we go to our key phrase. So this will form an open circuit and electricity cannot flow through. So this is the key phrase. The key phrase will probably 99% be used in electricity question, especially if it's an explain question. And we use it when they ask about whether the components function properly, or when the components does not function properly. In this case, the bulbs did not light up, didn't function properly. So we say it forms an open circuit and electricity cannot flow through. Alright, so again, the concept, plastic ruler is an insulator of electricity and electricity has to pass through object C to form a closed circuit. Okay, and you can also say, if you want, there's only one path for the electricity to flow to form a complete circuit, which is to pass through object C. But you can write like how I wrote down here, that'll be fine. Next question. At which positions in the circuit below should Jane place objects A, B, and C so that the most number of bulbs will lit up? Okay, so we know this box here, this particular box here, it has to be a conductor of electricity, or else it will not form a closed circuit. So we can put A here. A or B, it doesn't matter. Okay, the next one, whether we like it or not, this one has to be a conductor also, or else there's no other path for the electricity to flow. And if we put C here, it doesn't matter because it's just gonna block this path and electricity will not pass through this bulb. But the rest of the three bulbs, again, it's just about tracing. Okay, you can see it goes here and 1, 2, 3 bulbs light up. Next question. 3 different materials A, B, and C are each connected in separate circuits as shown. Only the bulb in the circuit with material B did not light up. So we know probably this is an insulator. Okay, so this is an insulator. We indicate the insulator. Now we put the materials in the circuit below and the battery is here. So now the electricity has 2 paths to go. When it leaves the battery, it can go up or down. But when it tries to go up, it will face this insulator. So there's no path through. So it will go down. When it goes down, it will go here. So only A and C lights up. Some students will say, but it still can go up. Alright, sure. Let's see what happens if it goes up. If it goes up, it passes through X. Okay, again, the mistake some students make, they will say, oh, see, it passes through bulb X. So it will light up. But in order for it to light up, it must form a closed circuit. That means it must return to the batteries. And in this case, it can't. So bulb X will not light up. Only bulb A and C will light up. Alright, so which bulbs X? Oh, sorry, that's my mistake. It's material A and C. The bulbs are Y and X only. Alright, so only bulb Y will light up. Alright. Oops. Okay, let's write down the answer. Okay, and we will use, again, our favorite question. So we will use our answering technique: observation, concept, and conclusion. So which bulb will light up? We say bulb Y. But this type of question, okay, this time around, it has what we call, or what I call, a direct answer, because it has a direct question. All right, bulb Y. You can say bulb Y. You can say bulb Y will, or you can say only bulb Y. That's even better. Only bulb Y will light up. If you have a direct answer, you will not have a conclusion, and I will show you why later on. So we'll start with the observation first. Observation. Okay, material B. Let me see, make sure, yes. This time they used the word material, they didn't use the word object. So you will see that sometimes I will pause to check what words are, or what words are used in the question. So here is material. It's not object. Okay, so it's material. So we say material B. Okay, material B. Let's continue. Material B is an insulator of electricity. Usually 2 marks question will have 2 concepts. Alright, so this is the first concept, insulator of electricity. The second concept is, so electricity cannot flow through material B. Okay. Okay. Actually, we don't need, again, same thing, insulator, you don't need to really mention. But if you mention, it doesn't matter. But the second concept, the one that we need to talk about, is the key phrase. So, okay, so it will form an open circuit, and electricity cannot flow through material B. Okay, so it's about the same. Just now I wanted to write down electricity cannot flow through material B. Okay, but then I just figured out, okay, we just talk about, instead of talking about that sentence alone, we'll use the key phrase, since I've already mentioned that in electricity we need to use the key phrase a lot. Okay, will form an open circuit. Sorry about that. Alright, let's make the correction. Okay, so it will form an open circuit. Okay, electricity cannot flow, and electricity cannot flow through material B. Sorry, this is actually the concept. So it will form an open circuit, and electricity cannot flow through material B. Okay, the second part is, so, okay, you can write down only a bulb X will not light up, or you can write down again, so electricity will not flow through bulb X. Okay, because there's 2 concepts, you can have 2 different concepts here. One is electricity does not flow through material B. Second is electricity will not flow through bulb X. So you see, if you don't like to use this so twice, you can change this to thus. Doesn't matter if you use so also. Okay, then the conclusion. You will see why we don't need conclusion here, because it's going to repeat our direct answer. The direct answer is, so only bulb Y will light up. That's why we don't need a conclusion if we have a direct answer. Okay, so that's something you can take note of here. We don't need this conclusion because we have a direct answer. Alright, last question for this part of electricity, and then we will continue in another video. The diagrams show a toy car and circuit A, which is found in the toy car. So it shows a toy car and circuit A. Without adding or removing anything from the circuit, suggest one change to circuit A to increase the brightness. Alright, so that's the key word. We want to increase brightness. Now, increasing brightness of light. Usually, if we can, we will add batteries. But here they say we cannot add anything. So the only way is to change the arrangement. Alright, so what can we do? We can arrange here they say the brightness of the light. So we're not going to use the word bulb. Right, so that's very important again, using words from the question itself. Arrange the lights in a parallel arrangement, okay, with all the other. Usually I'm going to use components, but again here the words used in this question is electrical parts. So I will say arrange the lights in a parallel arrangement with all the other parts. Okay, or you can say arrange the lights parallel to the other parts. But I'm not very keen with the second way of writing. Alright, I prefer the first way here. Okay, the reason is because this is parallel arrangement. Here is just parallel, so it's better to use parallel arrangement. So arrange the lights in a parallel arrangement with all the other parts. Okay, arrange the light parallel to the other parts in the circuit if you want, also not an issue. So let's just add that. Okay, to all the other parts in the circuit also can, no problem. Alright, so again, the best is if you can check with your teacher how they want you to phrase, and then you just tweak it to how they want you to phrase. So usually there will be a keyword. They will tell you, oh, we need you to write this down, or we need you to write this in a certain way. So you just need to adapt to that. Okay, for example, this case they say, oh, you need to have the word parallel arrangements. Then you don't use the second one, you use the first one. Arrange the lights in a parallel arrangement with all the other parts. If they say, oh, it's okay, you can just say arrange the light in parallel to the other parts in the circuit. Not an issue. Okay, so again, best practice is to check with your teacher how they want you to write, because again, different school, they have slightly different criteria. Alright, so if this has been useful, please do consider subscribing, and we will continue with the rest of the questions in the next part. And please check the description for the link to download these questions. Alright, thank you very much, and see you in the next video.